Hi guys, in this video I am going to solve an example. This is our first example. Let's look at the question. When I look at the question, the first thing I see that this is a common common source amplifier. We apply input at the gate side and take the output at the drain side. So let's look at the first question, and beta is given as 6 milliampere per volt square. Beta is equals to un Cox W over L. I mean beta is our Kn value, and V threshold is given as -1. Remember, in Mosfet V threshold is negative. So in A, it is what should be our gate 2 in order to get ID equals 2 milliampere in DC case. Remember, in DC case, capacitors are open circuited, so there will be no current passing through this side, also this side, also this side. So my circuit in DC case becomes like this. This is 1 mega. Our gate 2 is wanted to be known. Here 12 volts. Here our source 220, and here there is RD, which is 1K, and sorry, this is not nmos, this is pmos. So here it will be like this. So in this question, if ID is 2 milliampere, I can find V source. V source is 12 minus 0.22k times 2 milli times k means it's 1, so it is this is 0.44, so 11.56. V source equals 11.56. And if I know ID, which is 2 milliampere, I can write ID equation, which is 1 over 2 Kn, and Kn is given as 6 milliampere per volt square times VGS minus absolute value of VT. Remember, this is pmos, so in pmos we source at the higher potential, so we take V source G minus absolute value of V threshold, and absolute value of V threshold is 1 square. So if I make the necessary cancellations here, 0.667 equals V source G minus 1 square. So So 0.817 equals V source G minus 1. So V source G equals 1.817. I'm checking, and this is true. And if I know V source, I can find V gate. V source equals 11.56 minus V gate equals 1.817. If I subtract 1.817, sorry, minus 1.817, V gate equals 9.843. Okay, if I know V gate, I can find R gate too. How? Think like this. This is 12 volts. R gate 2 is not known. Here I know V gate, and here there is 1 mega. And remember, in DC case, in Mosfet, there is no gate current. This current is 0. So I can find the current flowing through these resistors. Simply V gate over 1 mega will give me the current. So I R gate 2 equals 9.843 divided by 1 mega, it is equals 9.743 microamperes. And if I know V gate, so 12 minus 9.843 equals R gate 2 times 9.743 microamperes. So 2.257 equals R gate 2 times 9.843 times 10 to the minus 6 Okay, so R gate 2 here, I have found 221.653K. Okay, we have found the value of R gate 2. In the B, find the power dissipated on the Mosfet. What is the power dissipated on Mosfet? Power dissipated on the Mosfet equals equals V source T times the current through it. I mean, this is the voltage through the Mosfet, and this is the current through the Mosfet. I know that ID is 2 milliampere. What is V source drain? We should find V drain, and it is easy. Look at here, in DC case, ID is 2 milliampere flowing through here. This is 1K, this is ground, so V drain equals 2 volts. So I know V source equals 11.56. So V source drain becomes 9.56 times 2 milliampere, and it is equals to 19.11 milliwatts. So this is B. Find the AC input resistance. Okay guys, right now I want to show you something. Remember my input and output resistances video. In that video I have told you that, for example, what is the input resistance seen at the gate of the Mosfet? It is infinite. You should know it by heart. So in AC case, this DC voltage supply will be grounded. So what is input resistance? Input resistance simply becomes R gate 1 parallel R gate 2. So what is R gate 1 parallel R gate 2? 221K parallel 1 mega. Let's calculate this. It is 187.652K. That's it guys. In this section, find the AC gain of the circuit. Okay. Also, I have gave this necessary formula in my AC input and output resistances video. What was V output over VI? Let's look at the circuit. This is common source. So the formula was minus GM R drain over that's it. Minus GM R drain over 1 plus GM R source. But be careful, there is no R source component in this question. Why? Because in AC case this capacitor will be short circuited. Look at here. So our source will be, this capacitor will be short circuited, so our source will be between two grounded, so there will be no source resistance in AC case. So my formula becomes minus Gm times Rd. So what is Gm? Let's calculate the Gm first for finding gain. Gm equals 2 times beta is 6 milliampere per volt square and current is 2 milliampere per square, so Gm equals 2 times 10 to the minus 6 caret this 4.9. It is 4.9 millisiemens. So gain is minus Gm times Rd. What is Rd? Look at here. By the way, I mean this is not VO over VI. Sorry, this is VO over V gate. V gate, so why? Because V gate over VI component, there is V gate over VI component in gain. So what is RD? What we see in AC case, this capacitor is grounded, and in drain case what we see is 1K parallel 5K. So V output over V gate equals 4.9 times 5K parallel 1K, and there is minus sign here. 5K parallel 1K, it is 5 over 6, I think. 5 over 6 makes 0.83K. And it is minus 4.087. Sorry, 67. 67. So this is V output over V gate. What is V gate over VI? Simply resistive divider. Look at the circuits. In AC case, we have find D. Now we are trying to find section E. So in AC case, there is, what is in AC case? There is here VI, here R source, and here R1 parallel R2, and simply this is my Ri. We have found Ri, it is 187K. What is R source? It is 50K. So V gate over Vi equals 187K over 227K, and it is equals 0.82. So total gain is the multiplication of this V out over V gate equals times 4.06 3.35 minus 3.35, and that's it, guys. The question is I have solved the question. We have found all the information that wanted. So that's it for today, guys. See you at the next video. Take care of yourself.